So let's look at this graph. On the x-axis here, we have time, and then on the y-axis here, we have pressure. So we're looking at the changes in pressure over time. There are three lines on this graph. The red line here represents the ventricles. Again, right or left doesn't matter. Represents the ventricles. The blue line here represents the atria. And then the black line here will represent the arteries. The aorta is a big artery in the body. Okay, so we're looking at the relative changes in pressure for those three places. Let's start here at the beginning, because again, even though this is a cycle, this is just where we tend to start, the ventricular filling phase. So if the ventricles are filling, the only way they could be filling is if they are the lowest pressure. So see here, this red line, the pressure in the ventricles is the lowest point. Again, everything flows towards downhill, so the blood will be flowing towards the lowest pressure in the ventricles. And the AV valves will be open. That's how the blood gets through it into the ventricles. But the semilunar valves will be closed because the pressure in the ventricles is less than the pressure in the arteries. So remember, AV valves, you compare the ventricle and the atria. For the semilunar valves, you compare the ventricles and the arteries. Okay, now at this point, the ventricles begin to contract, and as they contract, you see a rapid increase in pressure. See that? So the increase in pressure, the ventricles are contracting. At this point right here, the pressure in the ventricles is now greater, exceeds the pressure in the arteries. Sorry, say that again. Pressure in the atria. So if the pressure in the atria is now greater than the pressure in the ventricles, what happens at this point? That causes the AV valves to close. Okay, so at this point where the pressure lines cross, such that the ventricle pressure is now greater than the atria pressure, the AV valves are going to close. But look, even though the pressure is increasing, it's still less than the pressure in the arteries. So what's happening with the semilunar valves at this point? They are still closed. Okay, so at this point, both the AV valves and the semilunar valves are closed. And if they're both closed, nothing's going nowhere. Nothing's going anywhere. Bad grammar. So that would be the isovolumetric contraction. The ventricles are contracting, but the blood is not moving. Okay, now let's bring us to this point right here. At this point right here, the pressure in the ventricles is now the greatest pressure. It is now greater than the pressure in the arteries, and that causes the semilunar valves to open, and as they open, that allows the blood to flow from the ventricles down up into the arteries. Okay, so if the blood is going out of the ventricles into the arteries, that is called ventricular ejection. It's ejecting it out into the arteries. At this point, the pressure in the ventricles is now greater than the pressure in the arteries and still greater than the pressure in the atria. Okay, so that means that the AV valves are continuing to be closed as they've closed over here, but the AV valves are now open, allowing the blood to move out into the arteries. Now we have the ventricles beginning to relax, and as they relax, the pressure is going to decline. At this point right here, the pressure in the ventricles now becomes less than the pressure in the arteries. As it becomes less than the pressure in the arteries, that makes it so that the blood tries to flow back into the ventricles, causing the semilunar valves to close. So at this point where it crosses, that's where the semilunar valves are going to close. What about the AV valves? The AV valves are also still closed because the pressure in the atria continues to still be less than the pressure in the ventricles. So at this point, the AV valves are closed and the semilunar valves are closed. So what phase is this? This is isovolumetric relaxation, because the ventricles are relaxing, but the blood is not going anywhere yet. No change in volume. Okay, so as the ventricles continue to relax, at some point it'll make it so that the pressure in the ventricles now becomes less than the pressure in the atria. That makes it so that the blood now is flowing from the atria down into the ventricles, and so now the AV valves open again. So where would we be here? If the pressure in the ventricles is the lowest one and the blood is going into the ventricles, what phase are we in? This is also the ventricular filling phase. So this ventricular filling phase starts here and then continues on over to here. So remember, this is a circular cycle all the way through. Now, let's briefly go back to this piece that I kind of skipped. This little uptick right here, that's called the Dicrotic Notch. And basically what this is because the semilunar valves are closed, that kind of makes a backlog where the blood kind of comes together in that one spot. And that's going to cause that increase in pressure in the arteries here. And that helps maintain the blood flow even when the ventricles are relaxing. I'm not going to ask you about that one. I just want you to know about it. Okay. I know that's a lot. You might need to watch it a couple of times.